Good evening from Los Angeles. I'm really excited for week number 1 of General Chemistry 2. My name is Marion Steiner, and this here is Dr. Bailey. Say hi, Dr. Bailey. Dr. Bailey is going to join us for a second, so she doesn't bark. She is 8.5 weeks old and not understanding any of this human life. So just finished General Chemistry 1, went by really fast, so I'm excited for this week, General Chemistry 2. This lab is definitely my favorite part of the class, and today we're doing Advanced Concept Presentation 1 and looking at gummy bears. It's also an excuse to eat some gummy bears, which I have done today. So we all know that gummy bears are made up of 3 things, sugar, starch, and gelatin. We also know that gelatin is a polymer, which forms a 3-dimensional structure which gives the gummy bear its shape. They start off as a liquid and cool into a chewy gummy solution, and that's what we eat today, or I ate lots of today. The gummy bears are chewy because of gelatin, whose molecules are chain-like and create a solid matrix. Okay, Dr. Bailey is over it, so we're going to put her down now. Okay. Today we are looking at whether or not gummy bears will swell when placed in certain types of liquid. Earlier today I bought a pack of gummy bears, and I've been soaking them in water for the past 7 hours. The first gummy bear has been soaking in water, which is right here. This is the green gummy bear. Let's see if we can't really see, but I'll pull it out in a second so you can see. So the first one is the green gummy bear, which was soaked in water. And the second gummy bear was soaking in a saturated saltwater solution, which is right here, and this is the red gummy bear. So now we're going to remove both gummy bears and compare their sizes to see if we have anything different that happened to them compared with a normal gummy bear. So first let's compare a normal gummy bear. So we'll take this clear gummy bear right here, and I'm going to stick it on a plate, and I'll show you guys when we're done. So here is the plate, and we'll try and angle it down. So we have the normal gummy bear right there. So now let's take the gummy bear that's been in water. Let's fish out this little green guy right here. He's almost dissolved, actually. Oh goodness, this is harder than I thought. He feels very gelatin-like. Oh my, he's humongous. Now let's fish out our gummy bear that's been in salt water. Oh gosh, and I'm making a mess here. Also very hard to fish out. He also feels very dissolved. Okay, so now we have our 3 gummy bears. So let's compare their sizes and see if we have any different. So I'm going to pull this. Let's try and separate them. So now we have them all right here. So here is our first gummy bear that hasn't been soaked. This is the green gummy bear that was soaked in water. And this is the red gummy bear that was soaked in the saltwater solution. So there's definitely a difference. The green gummy bear is very swollen. The red gummy bear is swollen a little bit, but nothing comparative to the green gummy bear. And you can also definitely see the sizes compared to the other one. So why is this happening? So gummy bears contain no water. When you add the gummy bear to water like we did today, it will swell until it reaches a point where the water concentrates outside of the gummy bear is equal to what is in the inside. This should also happen in salt water, but we shall see. We saw that when my experiment turned out questionable, but definitely the green and the red bears, you can see how swollen they are. So let's talk about the water bear. A water bear has expanded for sure as water moved by diffusion through the bear's semi-permeable membrane to reach an isotonic state where the concentration of water molecules inside and outside the bear were the same. So now let's talk about the bear in the saltwater. It doesn't appear that there was any change in the bear. It's definitely permeated I shouldn't say there's any change. You can definitely see the difference. It's just not as swollen as the gummy bear that was in the water. Apologize for Dr. Bailey and his squeaking squirrel in the background. It definitely it shrank a little bit compared to what was in the green gummy bear. Our first bear's gelatin construction caused it to hold its shape and size for the most part, even when water leaves the bear. The shrinkage was caused by osmosis from the water leaving the gummy bear. So there we have it. That's pretty much what happened for our interactive presentation today. Thanks for having me for week number 1, and I will see you again next week. Have a wonderful weekend, and bye for now. And there is our gummy bears. And I have snacks for dealing with Dr. Bailey later tonight. Say bye, Dr. Bailey. Bye for now.